Welcome back. Let us go through the question. A body of mass 2 kg initially at rest moves under the action of an applied horizontal force of 7 Newton on a table with coefficient of kinetic friction 0.1. Compute the work done by the applied force in 10 seconds. So using Newton's law, we can write A equals to F by M. Now the value of F is given as 7 Newton and the mass of the body is 2 kg. So putting those values, we get the A to be 3.5 meter per second square. The frictional force is given by mu mg. Now the value of mu is 0.1. So frictional force is 1.96 Newton. Its direction will be opposite to the direction of motion. Thus acceleration produced will be negative. That is A equals minus 1.96 divided by 2, which gives us the value minus 0.98 meter per second square. Thus the net acceleration is 3.5 minus 0.98 equals 2.52 meter per second square. So the total distance traveled is given by this particular formula, which is S equals to ut plus half at square, and we put the value of A to be 2.52 meter per second square as we have calculated, and T is given there in the question, so it's given 10. So putting out all these values, we find out S to be 126 meter. So the displacement is 126 meter. Hence the work done by applied force is given by Fs. Now we know the value of F, we know the value of S, so eventually we get the work done to be 882 joule. So the next question asks, a body of mass 2 kg initially at rest moves under the action of an applied horizontal force of 7 Newton on a table with coefficient of kinetic friction 0.1. Compute the work done by friction in 10 seconds. So the work done by frictional force will be negative as the force opposes the motion, and we know the formula W equals Fs. So minus 1.96 into 126 gives us minus 247 joule. Compute the work done by the net force on the body in 10 seconds. The net work done will be the sum of the work done by applied force and work done by frictional force. So 882 minus 247, which gives us 635 joule. Compute the change in kinetic energy of the body in 10 seconds. It is given that initial velocity is 0. The final velocity can be calculated by the equation of motion v equals u plus at. Now u is 0 as there is no initial velocity, and a we already have found out, t we know, so it is coming out to be 25.2 meter per second. The change in kinetic energy is half mv square minus half mu square. The second term would be 0 as u is 0. So we put the value of m and v here and eventually find it to be 635 joule.